So the next is hyperconjugation. When is your exam, Jabita?
February 6th.
Chemistry, or it is starting on February 6th?
Starting on February 6th.
Starting on February 6th. Okay, fine. ठीक है. So I have to call you on Saturday or Sunday किसी एक दिन. I will message you. Okay, Jabita? For the Dumas method, Zeldal method, and
Sir,
chromatography part.
sir,
ठीक है?
I will
Fine.
not be available on Saturday and Sundays.
अच्छा, सैटरडे संडे दोनों दिन नहीं?
No, no, sir. In Saturday, Sunday, I won't be available because of my practical exams.
You will not be available both the days,
Yeah,
even on in the evening also.
yes, sir. Because next day I have another practical exam. So,
When is your practical? Monday.
Sunday.
Sunday is your practical. No, so Sunday you can come, na?
Sir, next day I have my pre-board exam also.
Friday? Friday भी नहीं, because Saturday you will be having practicals, I guess, na?
No, Friday I have prayer.
Friday you have prayer. Okay, fine. But you'll be fine if I do it later on then, na? The next week maybe.
On January only possible.
January only, na? Oh, there are
Mm.
2 weeks, 3 weeks remaining in January, na? This week, the next week, the next week.
Yes, sir.
है ना? Also, I will see if it is possible on any Monday, Tuesday, Wednesday, Thursday of the next week. Then also I will do. Fine.
Okay, sir.
Okay. Acha, you are available but in the morning I cannot do at any time right now. But khair, we will see. It will be only one class, one lecture. Okay. So what is hyperconjugation? So, we have seen three things. We have seen the shifting of sigma bond, that is the inductive effect, and we have seen the transfer of pi electrons, which is the resonance effect. And now we have the transfer of sigma bond, which is hyperconjugation, and it happens in certain cases. So what is hyperconjugation? First of all, it is the delocalization. That means shifting. है ना? It is complete transfer of electrons. Delocalization of, please write this with me. Delocalization of sigma, that is CH bond, CH bond electron with pi bond or positive charge or free radical और फ्री रेडिकल. ठीक है, इन तीनों के साथ डिलोकलाइजेशन को ही क्या बोला जाता है? It is known as hyperconjugation. Now, how it everything happens that we will explain, but these are few things that you should just know. What is hyperconjugation? Delocalization of CH bond, sigma bond with pi or positive or free radical. Also, delocalization is also known as a few. Sorry, hyperconjugation is known as a few more things. Hyperconjugation HC है ना, is AKA is also known as no bond resonance, and breaker Nathan effect. ठीक है, जल्दी copy this down. Then we will see a video which will explain the hyperconjugation part more effectively. Ali, when is your exam, Ali? Ali, did you get any dates?
No, sir.
Okay, just give me a second. Jasleen ka, let me write it somewhere. Jasleen, you have on 13th आप कह रहे थे ना? 13th 16 क्या कह रहे थे जसलीन?
13th, sir.
13th से start है. And Giobita, it is starting on 6th. Shaima, when is it starting for you, Shaima? The annual exam?
Sir, starting on 2nd Feb and chemistry is on 6th.
2nd Feb, fine. 2nd Feb. And Zainab, when is it starting?
Starting on 2nd Feb.
2nd Feb? अच्छा, you both are in same school, I guess, na?
Yes, sir.
Shaima and हाँ जी, fine. Please raise your hand if you're done. Waiting for Jobita, Jasleen and Shaima. Zainab, Jasleen का हो गया था, I think, right? हाँ. Waiting for Jobita, Shaima and okay, Shaima and Zainab. Waiting for Shaima and Zainab. Write this down, then I will explain it, the hyperconjugation. Then I will also show you a video that will explain it more. Shaima done, Zainab done. Okay, fine. See. देखिए, what is going to happen in hyperconjugation? होता क्या है वो हम आपको पहले बता रहे हैं. Then how we are going to study it, that is another thing. So carbon with a, let's start with a positive charge. Maybe it is having positive charge, and here you have a CH3. So basically CH3 में I'm only showing at least you have one CH bond. So CH bond will be sp3 of this carbon atom. It will be bonded with hydrogen ka S. Right. So this is the CH bond actually, in which what are the orbitals which is having intermixing or which are having bonded. So it is the sp3 of carbon and the S of hydrogen atom. They are bonded like this. Now these are having electrons here, है ना? यहाँ पे क्या है आपके पास? यहाँ पे electrons है. And we know that electrons are a wave in nature. And just nearby we are having what? There are two groups here, है ना? It doesn't really matter. We should have at least one CH bond. Now, the electrons here, it is present, and these electrons are having wave nature. And just adjacent to them, there is a positive charge. So obviously, sometimes the electron will shift this side. Sometimes the positive charge, this particular positive charge is going to attract the electrons. Which electrons? The CH bond electrons. It is going to be attracted by the positive charge. And for a millisecond, maybe it can move also. The complete electrons will move here. And what is going to happen then? Carbon, double bond carbon will be there. The two groups here and the two groups here are as it is. And this hydrogen has lost a bond. That means it is going to be H positive. Fine. So what is the change here actually? So C positive to H positive. So H positive is quite stable if I compare with C positive, because carbon and hydrogen, which is more electronegative. So obviously carbon is more electronegative. Carbon will not like to have a positive charge. Fine. In that sense, it is possible. But again, what is going to happen? This will go here, and it is going to show what? It is again going to be recaptured by this particular carbon atom. And तो ये होता रहेगा बार बार, होता रहेगा बार बार. So we can say that if you have a carbon atom which is having positive charge, इसके adjacent में carbon atom है, and here there is one CH bond. So this particular CH bond here, it is what? It is not a complete single bond, it is a partial single bond, है ना? Because it is sometimes shifting there. Now let me show you a video which is going to explain it furthermore. So can you guys see this? Yes or no?
Yes, sir.
Fine. Now here we have two different models. The first one, it is a methyl carbocation in which you are only having a carbon atom with three hydrogens. Hydrogen, hydrogen, and hydrogen. So this is a methyl carbocation. This one here, it is an ethyl carbocation. The black one is carbon. So here we have two carbon atoms. This is an ethyl. You can see this bonded with three hydrogens. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Methyl and ethyl carbocations. Now let's see what happens. Again, the same thing. This is the sp3 of the carbon atom, and then you will also see, you will not see the hydrogen because it is the CH sigma molecular orbital. And what I showed was the VBT picture. This is the MOT picture in which you have one bond, the carbons sp3 and the hydrogens s. They have intermixed with a linear combination of atomic orbital, and it has this type of molecular orbital. Fine, but it is the same thing. The CH bond is like this, and it is having two electrons. So you will also see two electrons in a few seconds, I guess. Yeah, it is having CH bonding electrons, and these bonding electrons will be moving. They will start moving in a few seconds. Yeah, they are going to move because of the obvious wave nature, you know. See, they are moving, and sometimes it is going to go to the positive charge also, because positive charge will attract the electrons. And as soon as it goes towards the positive charge, then what's going to happen? The CH bond is going to break. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Fine. ठीक है. So next we have, ये हो रहा है, but it is not going to be like, ये ऐसा बहुत important कुछ नहीं था समझना आपके लिए. What is important for you is to remember a few things, that is the conditions for hyperconjugation. This is very important. Please write this with me. Conditions for hyperconjugation. There are two conditions. Number one, the condition is at least one carbon atom, at least one carbon atom should be sp2. Now, when I say sp2, it should be either a carbocation, or it should be a carbon free radical, or it should be a carbon double bond. इन तीनों में से कोई एक चीज होना चाहिए ना, कार्बन कार्बन डबल बॉन्ड होना चाहिए एटलीस्ट. सेकंड कंडीशन इज दैट carbon adjacent to carbon adjacent to sp2 carbon that is the alpha carbon should have at least one hydrogen. Fine. These are the two conditions. Then we will practice a few questions, उससे आपको समझ में आ जाएगा. First condition, one of these things should be present, C positive or C radical or C double bond. The other thing is that it should have a adjacent carbon. That means there should be an alpha carbon. That alpha carbon should have hydrogen. Got this? Yes or no? Please tell me, guys.
Yes, sir.
Write this down. Raise your hand if you're done. Waiting for Ali, Jobita, and Shaima. Just waiting for Shaima. Shaima, raise your hand if you're done. ठीक है, ठीक है. For example, number 1, CH3 positive. Do we have, is the first condition satisfied? I hope you can see the first condition. थोड़ा दिमाग लगा के थोड़ा जल्दी आंसर करिएगा. Is the first condition satisfied? Do we have a carbon atom with a positive radical of the carbon-carbon double bond? Yes or no?
Yes, sir.
The first condition it is satisfied. What about the second condition? Is there any adjacent carbon? This is the sp2 carbon, है ना? This is the sp2 carbon. इसके बगल में कोई carbon है? Is there any carbon adjacent to it?
No, sir.
No. So it is not going to show. क्या ये hyperconjugation show करेगा? It will not show hyperconjugation. Make sense? Yes or no? Please tell me.
Yes.
Yes, sir.
CH3. Then you have. Similarly, if I say CH3 radical, है ना? So CH3 radical में first condition is satisfied. Second condition it is not satisfying, right? Then if I have CH3 single bond CH2 positive. First condition is satisfied, yes or no? What about the second condition?
Yes, sir.
Second condition, is it satisfied? देखिए जरा. This is my carbocation, that is the sp2 carbon. Adjacent to it, we have the alpha carbon. Is this alpha carbon having hydrogen? Yes, this alpha carbon is also having hydrogen. So the second condition, it is also satisfied. So it is going to show hyperconjugation. तो यहाँ पर ये hyperconjugation show करेगा. Now the next question is, how many hyperconjugating structure it can show? Then what you have to see, the alpha hydrogen. This alpha carbon, it is having how many hydrogens? The alpha hydrogen, it is equal to 3. So it will make 3 hyperconjugating structure. Make sense? Yes or no? Please tell me.
Yes, sir.
अब सवाल है, carbon with a positive charge, there is one hydrogen. Here it is having CH3. Here also it is having CH3. Now see. So you can see that the first condition is satisfied. This is my sp2 carbon atom, and it is having this alpha and this alpha. Fine. Now how many alpha hydrogen? So alpha hydrogen will be equal to यहाँ से 3 और यहाँ से 3, how much? 6 alpha hydrogen. So 6 hyperconjugating structures will be formed by this particular molecule, this carbocation. Similarly, if I have carbon and all the 3 bonds are CH3. So here we have CH3. Here also we have CH3. Here also we have CH3. And here we have, let us suppose, positive charge. So this carbon atom is my sp2 carbon atom. And with respect to this sp2 carbon or the carbocation, I have this alpha. This is also alpha. And this is also alpha. The total number of alpha hydrogen will be equal to 9, and hence 9 hyperconjugating structures. Does this make sense? Yes or no? Please tell me.
Yes, sir.
Okay. Similarly, now let us see for double bond, है ना? Radical and carbocation you can exchange, है ना? जो कि हमने carbocation बनाया, you can put a radical here. It will be the same thing. Now for double bond CH2 double bond CH2. Do I have sp2 carbon? Yes, this is sp2 and this is also sp2. Do I have anything which is adjacent? No. So the first condition is satisfied. The second condition, it is not satisfied. That means this particular alkene, it is not going to show any hyperconjugation. Let us suppose if you have something like this. Double bond. So this carbon atom, it is sp2. This carbon atom, it is sp2. With respect to sp2, we have to see the alpha carbon. So this is my alpha carbon. If this sp2 does not have any alpha carbon, so it doesn't really matter. How many alpha hydrogen? So here we have 3 alpha hydrogen. Similarly, if I have something like this, a double bond here, this is my sp2 carbon. This is also sp2 carbon. This is with respect to sp2, this is alpha, and this is also alpha. So this is having 3 hydrogens, and this one is having also 3 hydrogens. The total number of alpha hydrogen will be equal to 6. So you copy this down. Let me know if you have any doubt. Waiting for Jobita, Jasleen, Shaima, and Zainab. Waiting for Jasleen, Shaima, and Zainab. Just waiting for Zainab. Okay, going on. Determine number of alpha hydrogen in following. एक काम करते हैं, इसको हटाइए, ये मत सोचिए, ऐसे मत लिखिए. First of all, I will write a few things. First thing, stability of carbocation, carbon free radical, and alkene is given by hyperconjugation. And for all of these, the stability depends on number of hyperconjugating structure, and which is directly proportional to the number of alpha hydrogen. ठीक है. So basically I will ask for the compare the stability. The question is compare stability of following. Compare stability of following. Can I move on? सवाल दें हम? Yes or no? Please tell me, guys.
Yes, sir.
मैथ क्लास कब है आपकी यार, अली? Eight p.m. What's the time right now?
7:59.
Okay. Learnivio का मैथ्स क्लास है.
Yes, sir.
Why at this time? हाँ अली. Okay, fine. But it's been like half, मतलब आधे घंटे में ही मैथ्स क्लास आपका हो गया. प्लीज मैसेज कर दीजिए जरा, आप इसमें टीम को मैसेज कर दीजिए दैट राइट नाउ आई एम हैविंग केमिस्ट्री क्लास. ठीक है. नाउ व्हाट एवर यू फील इज मोर इम्पोर्टेंट, आप वहां पे चले जाइए, बट टेल द टीम. चलिए ठीक है. Please see here, then you can copy this down later on. You have just seen that this is having how many alpha hydrogen? There is 0 alpha hydrogen यहाँ पे, है ना? Here it is having how many alpha hydrogen? There are 3 alpha hydrogen. This is sp2 sp2. और यहाँ पे हमने देखा था अभी how many alpha hydrogen it is having? It is having 6 alpha hydrogen, right? यहाँ पे 3 और यहाँ पर 3, right? So this will be the order for stability. Similarly, here also we have seen that number of alpha hydrogen here it is equal to 9. Number of alpha hydrogen here it is equal to 3, and the number of alpha hydrogen here it is equal to 0. Yeah, okay, fine. So this is the most, and then this is more stable than at last this one. Try for the third one. Fourth, no, third. I will do for you the first one. है ना? This is sp2. This is also sp2. Here it is having how much? दो हाइड्रोजन यहाँ पे होगा ना, तो this is how many alpha hydrogen? There are 4 alpha hydrogens. Fine. के बाकी में देखिए फिर आप. Correct, Jasleen. So here also, here we have how many alpha hydrogen? It will be 2 plus 2, 4, and 3. That is 7 alpha hydrogen. And here we are going to have 3, 3, 6, and here we are going to have 10 alpha hydrogens, right? So the more number of alpha hydrogens, the more will be the stability. Please copy this down. Waiting for Jovita and Shaima. Just waiting for Shaima. Now, next thing is that in toluene we have benzene ring with a CH3. ठीक है, यहाँ पे अगर आप देखें, so this is also going to show hyperconjugation because see this is the sp2 carbon and here we are having alpha carbon, this is having 3 hydrogens, fine. Now what is going to happen? How does it show hyperconjugation like this? This hydrogen CH bond, it shifts here and this pi bond is going to shift here. You will get the first hyperconjugating structure which will look something like this. Here you will have double bond. The carbon will be now having 2 hydrogens. There will be one H plus which is having a broken bond. This pi bond will be as it is, this pi bond will be as it is. There will be a negative charge here because this pi bond is shifting on this carbon atom. And we have seen this particular type of Rathband brief before also. Now this negative charge will come here, and this pi bond will become negative charge. And then further the hyperconjugating structure can move on. Now we know the conclusion what is going to actually happen at last is that we are going to get a benzene ring in which all of these bonds are going to be partial double bond character. And if I look at this particular CH bond, then in this case, this carbon and hydrogen, it is having a single bond as well as there is a partial double bond character here, because here it is single, here it is double and everything. If I talk about the hydrogen, then all the hydrogens are having partial single bond, and partial single bond. Fine. These things are not very important. The important thing is that this carbon atom, the ortho carbon atom, will get a delta negative charge because it is having negative. The electron density is increasing on the ortho and the para positions because of CH3. So we can say that CH3 acts as plus H group and increases electron density at ortho and para positions. Copy this down. Done. Okay. Please see. Next, I'm just going to revise a few things. ठीक है, इसको आप लोग देखिए जरा. All of these things are there already in your notes, है ना? बस इसको दोबारा एक बार देख लेते हैं हम लोग. Carboctan and carbon free radical. We already know that what is carboctan, what is carbon free radical. We have seen these intermediates, है ना? When we were talking about the homolytic fission and heterolytic fission. Fine. Now the stability of reactive intermediates. Now what carboctan will be more stable, what radical will be more stable. So उसके लिए carboctan and carbon free radical both are electron poor. They do not have the complete 8 electrons. If I talk about carbocation, then it has only 6 electrons. It has only 6 electrons. If I talk about carbon radical, it has only 7 electrons. So both of them, they are not having 8 electrons. That's why they are electron poor. If they are electron poor, then they will be stabilized by if I give them electron. They will be stabilized by electron donating effect and hyperconjugation. Hyperconjugation is always a plus effect, है ना? तो देता ही electron है. And they are going to be destabilized by electron withdrawing group. So the stability will be directly proportional to plus m, and it will be inversely proportional to minus m, directly proportional to hyperconjugation, and then directly proportional to plus I, and inversely to minus I. And if I talk about the strength of the different effects, then the mesomeric effect is the strongest. After that, we have the hyperconjugation, and the weakest effect is the inductive effect. ठीक है, इसको तो आप लोग लिख ही लीजिएगा. Mesomeric and then hyperconjugation and then inductive, है ना? For anything, if there is a molecule which is having a mesomeric effect and inductive effect, so we are going to treat mesomeric effect. We are going to check mesomeric effect. Then only we are going to see the inductive effect. Fine. Does this make sense? The 4 points. Yes or no? Please tell me.
Yes, sir.
Okay. Please copy this down. Stability of reactive intermediates. So you can also see that if you have plus ना, अगर आपके पास plus है कुछ electron deficient है, तो plus things are going to stabilize it ना. Plus m stabilize करेगा, plus I stabilize करेगा, minus m is going to destabilize it, minus I it is also going to destabilize it. Waiting for Jasleen, Shaima, and Zainab. Waiting for Jasleen and Zainab. Jasleen and Zainab, just waiting for you. Zainab, just waiting for you. Okay. Next is we are going to have carbonyl. So carbonyl, it is just completely opposite. So carbonyl, it has negative charge, so it is going to be stabilized by electron withdrawing groups and destabilized by electron donating group. Because when we have negative charge, then we need to lower the charge density. Hai na? How can we lower it? If I withdraw the electrons from there, that's why it is going to be stabilized by electron withdrawing. If something is going to withdraw the electron will be less, negative charge will be less, and it will be more stable. So it is going to be stabilized by minus I and minus m. So minus m directly proportional to minus m, and stability is inversely proportional to plus m, directly proportional to minus I and inversely proportional to plus I. Does this make sense? Yes or no? Please tell me.
Yes, sir.
Chaliye, please copy this down. Raise your hand if you're done. ठीक है. Now there is a topic of there are different types of reactions: substitution, elimination, addition, and rearrangement. So rather than talking about it, I'm going to give you guys a questions and we can discuss this question. ठीक है, ध्यान सुनिए जरा. ठीक है. First of all, let us look at this first question. आराम से देखिए, और कहीं देखने की जरूरत नहीं है आपको. Please leave your pen aside. You do not need to write these questions right now. आराम से देखिए सर. In the A compound, what is actually happening with the organic molecule? So this is the organic molecule. What is happening with it? When I see Br, it is getting replaced by SH. Can you guys see that? Yes or no? Please tell me.
Yes, sir.
Right. So it is a substitution reaction. Can we say that? Yes or no?
Yes,
We can
sir.
directly say that, right? It is a substitution reaction. Substitution. Fine. Now, next is you can see that there is a pi bond here which is getting broken. Can you see that?
Yes,
Yes or no?
sir.
This carbon atom, it is getting a chlorine, and this first carbon atom, it's going to chlorine, and this carbon atom, it is getting a hydrogen, right? H2, and here we have H3. So we are adding things here. Huh? So this is an addition reaction. Addition reaction हमेशा क्या होगा? There will be a pi bond. Pi टूट के pi will break. Pi breaks. Addition में it doesn't really matter, double है single. Pi bond is going to break. Pi breaks. और फिर दो sigma. Pi breaks and 2 sigma forms. 2 sigma bonds are formed. एक pi bond टूटेगा और 2 sigma बनेगा, या फिर 2 टूटेगा तो 4 sigma बन जाएंगे. Fine. Just the opposite of it is what it is: elimination reaction. You can see that hydrogen यहाँ से निकल रहा है, यहाँ से Br निकल रहा है, and that's why you are having CH2 and CH2. Can you see that? Yes or no?
Yes, sir.
This is known as elimination reaction, in which what is going to happen? 2 sigma breaks and pi forms. एक pi बनता है. And at last you can see that it is a rearrangement reaction. You can also see that it is, sir, यहाँ पे substitution भी हो रहा है, but it is not complete substitution. You can see that this last carbon atom, it is having OH, है ना? CH3 whole thrice, carbon, CH2. Now here we are not having even CH3 whole thrice, CH3 whole twice है, and Br जो है आपके पास OH की जगह Br नहीं लगा है. So there is some kind of rearrangement going on. The atoms के बीच में जो molecules के बीच में bonding है वही हमारे change हो रही है. So this type of reaction is known as rearrangement. You can write these 4 questions. Raise your hand if you're done. Waiting for Jasleen and Zainab. बड़े आगे.
No, sir.
चलिए.
Sir, 1 minute.
Okay. Raise your hand if you're done, guys. Waiting for Jasleen. ठीक है. Fine. So this is all about the chapter organic chemistry, and the only part which is remaining is the Zeldal method, Dumas method, the chromatography, partition chromatography, differential extraction, sublimation, crystallization, purification, and the methods of qualitative and quantitative analysis. ठीक है. Now for that, most of the schools they are not having that portion. Jovita के school में बचवा है, so I will ask Jovita to come in certain class. Today we are going to start now. Now we are going to start hydrocarbons. Now one more thing is that at what time are you guys free tomorrow? Do you have any class tomorrow, Jovita?
No, sir, but I have exam day after tomorrow.
What exam? Pre-board.
Bio-
You are not free tomorrow, Jasleen. You are not free in the sense like you are going somewhere, or you have any class
No, sir. I also have exam day after tomorrow.
day after. ये prelims type का है कुछ. फिर कैसे होगा यार? Hydrocarbon, I was thinking that I will take extra classes from Tuesday till like at least कल एक class ले लेते फिर Thursday को, and then maybe Friday, Saturday, Sunday में से कोई एक दिन. Okay, fair, fine. We will talk on Thursday. If tomorrow is not possible, then we are going. What about anyone else? Like if I can have a class, then you may can watch. Maybe you can watch the recording then after that. If recording is possible for you guys. Shaima, Jopita, Jasleen, Zainab, any one of you are free tomorrow for tomorrow class? What time you are free, Zainab? At what time are you free? You don't know what time you are free, Zainab. Sir, I have bio class from 6:30 to 8. After 8, you are free?
Sir, I'm going out of the lead.
So you're not free tomorrow.
Yes, sir. Around 5:30 I'll be free.
Around 5:30 you will be free. 5:30 कैसे?
Yes, sir.
So in India it will be what time?
Around 8.
8. What about before 5:30? Do you guys have school tomorrow?
Yes,
Zainab, you have school tomorrow?
yes, sir.
Acha, all of you will be having schools na because of the syllabus. Okay, fine. Tomorrow I think will possible नहीं है पर चलिए खैर. Hydrocarbons, it is divided into two categories. First of all, so for hydrocarbon, at least what we can do for today is that I will just explain things and I will give you the PDF. ठीक है? You can write it later on in the. अब बाद में इसको लिख सकते हैं. Fine. So आराम से सुनिए, पेन वगैरह छोड़ दीजिएगा, है ना? Just keep on listening and flip vertical, horizontal, horizontal. So hydrocarbons can be divided into two categories. First one is acyclic, and the other one is cyclic. Cyclic. Now, acyclic can be again divided into two categories. The first one is saturated. Now, in hydrocarbon saturated, we have only one category, that is alkane. है ना? या फिर इसको हम ऐसे लिख देते हैं, only one category, that is alkane, which have a general formula of CnH2n plus 2. Now, we have one more category, that is unsaturated hydrocarbons. Unsaturated. In unsaturated hydrocarbon, we have alkene, which have a general formula of CnH2n, and we also have alkyne, which has a general formula of CnH2n minus 2. In cyclic also we have two categories. One is alicyclic or aliphatic. You can write alicyclic. In alicyclic, we have a general formula that is, it is going to be something like this. These are alicyclic compounds, now which has at least one sp3 carbon atom. Okay? Then we have one more which is known as aromatic. We will learn about aromaticity later on, but right now you can understand that aromatic compound is anything which is having kind of benzene. In hydrocarbons at least it is going to be benzene containing compounds, है ना? इनको aromatic कहा जाता है. Fine. So this is the classification of hydrocarbons. Next is we have, so for the sequence of in hydrocarbons, the sequence will be alkane, alkene, and alkyne, and after that we will be having aromatic hydrocarbons or the benzene. तीनों के लिए we are going to learn about the first of all the method of preparation, and then we are going to learn about the chemical properties. ठीक है? So these are the two things that we are going to learn. Sometimes we will be also learning about the physical properties, but majority of the times it is going to be method of preparation and then the chemical properties. The good thing about alkene and alkyne is that both of these are going to show very similar chemical properties. So all the reactions of alkyne will be already studied in the alkene portion, and we are going to just revise it in the alkyne portion. Fine. So first, one more thing regarding saturated and unsaturated compound is that, for example, if I have saturated, so saturated hydrocarbons, I'm writing in short, saturated hydrocarbons cannot have more hydrogen atoms. More hydrogen atoms. For example, if I have two carbons, the maximum number of hydrogen that we can have is how much? It will be 6 hydrogens. And this is what this is alkane. When I have unsaturated hydrocarbon, unsaturated hydrocarbon can have more hydrogen atoms. Because let's suppose if you have carbon double bond carbon, there will be only two hydrogens, fine. But what is the maximum number of hydrogen if I have two carbon? The maximum number of hydrogen is 6 hydrogen. So दो कार्बन में 6 हाइड्रोजन मैक्सिमम हो सकते हैं. There can be 6 hydrogen at max if I have two carbon atoms. But right now how many carbons, how many hydrogens we are having? Only 4. इसमें आप हाइड्रोजन ऐड कर सकते हैं. You can add hydrogen here. Similar is the case for the carbon triple bond carbon also. Carbon triple bond carbon, and here I have hydrogen. So in this case also we can add hydrogen on this triple bond. Does this make sense? Yes or no? Please tell me. Regarding
Yes, sir.
saturated, है ना? The meaning of saturated is also that you cannot add anything else, right? If there is a saturated solution, you cannot add anything else, है ना? Unsaturated में you can add something. So similar is the case for saturated hydrocarbons and unsaturated. You can add more hydrogens or not add more hydrogens. ठीक है? Now moving on to alkenes. We'll first of all start with alkenes. Alkenes. And in this, the first thing that we are going to learn is the method of preparation of alkenes. MOP, method of preparation. Let me write it completely here. उसके बाद फिर आप लोग method of preparation. That is MOP. So in the method of preparation of alkanes, we have the first method of preparation, that is catalytic hydrogenation. Catalytic hydrogenation. First thing is that how you are going to grasp a few things, because these are the first time that the reactions are going to be present in the notebook. So ध्यान सुनिएगा. You are going to first of all see what bond is breaking. Then you are going to see what bond is forming. First of all, सबसे पहली चीज आपको ये देखनी है कौन से bond टूट रहा है, and then what bond is adding. So there are two steps. Organic chemistry में one thing is that I'm a few tips for organic chemistry. Let's hear it right now. Organic chemistry, it is very much process oriented. Like the way I am doing the question, it is going to be the only way which is going to be the correct way. Okay? Because in, see, for example, if you have suppose equilibrium, it doesn't really matter how you are solving the question. And if you're solving it with the correct formula and you are the whatever mathematics is being used, no matter whether you are doing it what way, but if you're doing it correctly, the rules of mathematics are followed, then it's fine. But in this case, there will be only one process, one sequence that you have to follow, and that is going to be the correct one. It is not very much algorithmic that you can have this way or that way. It's very much process oriented. And also, for example, what do I say? It is also very much situational, in the sense that, for example, it is more like what I can say. One of the examples is that it is like riding a bicycle. So you have to ride the bicycle. You cannot learn riding bicycle if you if you are going to just see the things. And if you see me doing organic chemistry, you're not going to learn organic chemistry. You have to start drawing things and doing things. With that said, organic chemistry is very much visual. It is very visual. It is very visual type of topic. None of the topic is very visual. If you're studying mathematics, then maybe conic section and straight lines and geometry, these things are maybe somewhat visual. Otherwise, if I talk about physics and what do I say, biology, then I don't think it is very much visual. Physics, maybe whenever you make the free body diagram in Newton's laws of motion, that may be a bit visual, but again, it's not very much visual. It is very much mathematical physics also. Organic chemistry is the only portion. In chemistry also, nothing is very much visual apart from organic chemistry. Whenever you are solving the questions also, you have to be very much, you have to draw the things, you have to see things. And you don't have to calculate things. And you have to, majority times you have to count things. That's it. Number of hydrogen kitna hai, alpha hydrogen kitna hai, ye karna padega. Right? It is very visual, it is very process oriented, and it is also very situational in the sense that, for example, right now it is very much cold, right? So when you start a car, it may start automatically just by moving the key, but sometimes you have to give chalk, and if you know chalk. But more important is that, for example, riding a bike. If you're riding a bike, you can start with the self, but if it is very cold, then you have to kick it. Sometimes it does not even start with the kick. You have to give choke, and then it starts. So as per the different conditions, the reactions are going to change. So it is going to be so much situational. कि यहाँ पर ये भी मौजूद है तो क्या होगा, वहां पे ये भी मौजूद है तो क्या होगा, ठीक है. So you have to think in those ways. So first of all, it is process oriented, it is very visual, and it is very situational, है ना. सिचुएशन के हिसाब से चीजें चेंज होती जाएंगी, यानी वैसे कभी भी कुछ भी हो जाता है, बट इट्स नॉट लाइक दैट, है ना. यू हैव टू, फॉर एग्जाम्पल, अगर आप चाय बना रहे हैं और चाय में मान लेते हैं जो दूध आया है तो दूध थोड़ा पतला है, या फिर जो चाय पत्ती आई है वो चाय पत्ती अभी थोड़ी सी धीमी है, इट्स नॉट वेरी हार्श, यू आर गोइंग टू ऐड 2 more spoons ना. तो ऐसा नहीं है ना चाय बनाने का तरीका बार बार चेंज हो रहा है, इट्स लाइक यू हैव टू बी सिचुएशनल, सिचुएशन के हिसाब से आपको ऐड करना पड़ेगा. डज इट मेक सेंस, यस और नो, जसलीन, शायमा, जैनब?
Yes, sir.
ठीक है. तो इस तरह से बिल्कुल थोड़ा सोचना चालू कीजिए आप लोग ऑर्गेनिक केमिस्ट्री के बारे में, ठीक है. एंड इट विल हेल्प यू. एंड डू नॉट लाइक, आई विल टेल यू थिंग्स, स्मॉल छोटी छोटी चीजें. हाँ, एक और चीज आपको बताते हैं ऑर्गेनिक केमिस्ट्री के बाद, इट्स वेरी डिफरेंट, दैट इज व्हाई आई एम टेलिंग यू सो मच थिंग्स. इट इज लाइक हाउ यू स्टार्टेड लर्निंग टू मल्टीप्लाई एंड ऐड. फॉर एग्जांपल, व्हेन वी, बचपन में बिल्कुल जब हम लोग इस तरह से करते थे, 73 एंड हियर वी हैड, लेट अस सपोज व्हाट, 47. तो 7 3 10, वी डिड नॉट राइट 10 लाइक दिस ना, वी हैड टू, वेरी स्मॉल कंसेप्ट, दिस इज वेरी स्मॉल कॉन्सेप्ट ऑफ, क्या बोलते थे इसको, कैरी, है ना. यू हैव टू कैरी द 1 एंड राइट द 0, फाइन. तो ये बार छोटा कंसेप्ट है, लेकिन भूल जाते थे ना बचपन में, जैसे शायमान, जैनब, ये सुनो,
Yes, sir.
है ना. सेम थिंग इज गोइंग टू बी हैपनिंग विद ऑर्गेनिक केमिस्ट्री. एंड फिर आपने इसको रूल को याद किया क्या, आप ऐसे बैठ के रटते थे क्या रूल को? इफ द नंबर इज ग्रेटर देन, इफ द sum is greater than 2 digit, then carry. If the sum is greater than 2 digit, then carry. If the, you do not do that, right? Yes or no, Justine, Shaiman, Zainab?
Yes, sir.
What did you do in order to learn this? You practiced a lot of questions. That's the only thing that you are going to do in organic chemistry also. When you are going to practice reactions, then only वो reactions आएंगे बार बार, ठीक है. चलिए, with that said, let us start catalytic hydrogenation method of preparation. In this, what is going to happen? First of all, general overview. आपके पास अगर pi bond है, then it is going to get converted into CC. pi bond है, then it is going to get converted into CC single bond, ठीक है. For example, if you have carbon, double bond carbon, there are 2 groups attached here, there are 2 groups attached here, and you are going to add here H2. So that is hydrogenation. Catalytic means you can use a different type of catalyst. For example, C plus H2, this is hydrogenation. In the presence of, you can use nickel, or you can use palladium, or you can use platinum. The answer will be carbon with the 2 groups as it is. The pi bond will break to sigma bond. The 2 groups as it is. Both the carbon atom will get a hydrogen atom like this. Does it make sense? Yes or no? Please tell me.
Yes, sir.
If you have carbon carbon triple bond, and you add H2 in the presence of the same thing, that is nickel and PD and PT, then the carbon, the bond will be as it is. The pi bonds will be converted to sigmas. Pi bonds सारे टूट जाएंगे, carbon carbon pi bond. Above you will get 1 hydrogen and below you will get 1 hydrogen. 2 pi bonds break, so you will get 2 hydrogens, है ना? H and H, fine. So whether it is alkene or whether it is alkyne, all of them are going to get converted into alkane. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Yes,
ठीक है.
sir.
नेक्स्ट इज, लेट्स डू अ फ्यू क्वेश्चंस, है ना. फॉर एग्जांपल, बहुत ही आसान है. आई हैव 1 2 3 carbon atoms and an alkene of 3 carbons in the presence of H2 and nickel. Then what's going to happen? We're going to get an alkane of 3 carbon atoms. Does it make sense? Yes or no? Please tell me. If you have alkene of 4 carbon atoms and you are using H2 in the presence of PD, let us suppose, we're going to get an alkane of 4 carbon atoms. Does it make sense? Yes or no? बस आपको पाई बॉन्ड हटा देना है. आ रही बात समझ में?
Yes, sir.
H2 in the presence of, let us suppose, platinum, and here I have double bond, here also I have double bond. It doesn't really matter, it is going to do the complete reaction. यहाँ पर आपके पास ये pi bond टूट गया, वो pi bond टूट गया. If I have, let us suppose, benzene ring in which I have double bond double bond double bond, and I am using H2 in the presence of platinum, then nothing is going to happen. Why? Because the benzene ring, it is having aromatic nature and it cannot lose aromaticity at room temperature. So I will write, why does it not happen? Due to aromaticity of benzene. what is aromaticity वो आपको पता चल जाएगा, but in benzene this reaction is not going to happen due to aromaticity of benzene. Fine, this reaction does not happen. Does this whole thing make sense? Yes or no? You can write a few more reactions, है ना? For example, if you have, let us suppose 1 2 3 4 carbon atoms, यहाँ पे triple bond है, and here you have H2 in the presence of, let us suppose, nickel, so you'll get 4 carbon atoms. Fine. Then I'm going to give you 2 questions as a homework, है ना? ये तो आप लोग बाद में कॉपी कीजिएगा, तो यहाँ पर आप 2 सवाल कीजिएगा. What are the 2 questions that I should give? For example, let us suppose if you have something like this, and here you have double bond, just remove the double bond, that's it, है ना? This means the same reagent are being used here. Second, here you have double bond, ठीक है, same reagents are being used here. चलिए, got this? Yes or no? Please tell me.
Yes, sir.
Now, few things. एक सवाल ऐसा है एनसीईआरटी में, that identify Zainab, I will send you the PDF ना. Fine, ये हम PDF अभी क्लास के बाद ही भेज देंगे, ठीक है?
Yes, sir.
Okay. Identify the isomeric alkenes for preparation of ब्यूटेन. ठीक है, ध्यान सुनिएगा जरा, ठीक है, ध्यान सुनिएगा. डोंट राइट एनीथिंग डाउन, प्लीज डोंट राइट, है ना? यू आर नॉट राइटिंग गाइस ना, योर मेन फोकस शुड बी ऑन लिसनिंग राइट नाउ. फाइन, majority of the things you are going to learn right now only. Okay, as you know what I said, just remove the pi bond, and just remove the pi bond. Now what they are asking in this case is that what are the isomeric alkenes you have. That means there are multiple alkenes which can make butane. So what is butane? So butane is basically 4 carbon atoms. So butane, it can be made by, now there is for example, if you have A plus B gives C plus D, है ना? So this arrow in chemical reaction we called it gives, right? Jasleen, Shaima, and Zainab. We do not
Yes, sir.
say it as arrow. No? We do not say A plus B arrow C plus D. We say A plus B gives C plus D. A similar arrow, this is the reaction arrow. A similar arrow is there for, this is the arrow. It is known as retrosynthetic arrow. What arrow? Retrosynthetic arrow. When I write this, then it means this molecule can be made by A and B. For example, what I will write, C can be made by A and B. Does it make sense? Yes or no? What is this arrow?
Yes, sir.
Shaima and Zainab, do you guys understand what is it? Retrosynthetic arrow, right? C can be made by A and B. So this is used in organic chemistry a lot. Although it is not there in NCERT, neither in 11th standard nor in 12th standard. Maybe you will not even study this type of thing in BSc. Maybe अक्सर universities में MSc में ये पढ़ाया जाता है retrosynthetic arrow, but it's a very easy concept which makes life easier. This can be made by either this molecule, आप double bond यहाँ भी रख सकते हैं, or you can have this molecule. Yes or no? Correct? इसमें भी अगर आपने क्या किया, H2 in the presence of nickel किया, and इसमें भी जब आपने क्या किया, H2 in the presence of nickel किया, both of these are going to give you only what? A butane of 4 carbon atoms, alkane. Does it make sense?
Yes, sir.
So what are the 2 isomeric alkenes? So it is 2 butene. Now butene or 2 butene is the same thing, or 1 butene, or but 1 ene. That's the same thing. Does this make sense? Yes or no? Please tell me.
Yes, sir.
Make sense? Moving on. Another question. Can we prepare methane by catalytic hydrogenation? So the simple answer is no. Why? Because we have CH4, है ना? And catalytic hydrogenation, it needs an alkene. So catalytic hydrogenation में you need at least 2 carbon atom. Make sense? Yes or no? Please tell me. No. Why no? As you know that ना catalytic hydrogenation में क्या चाहिए? Alkene or alkyne. We need alkene or alkyne. So neither alkene nor alkyne can be made by one carbon atom. Both of them, they need at least 2 carbon atom in order to have carbon-carbon pi bond. Yes or no? As
Yes, sir.
there cannot be, C लिखना है C. Cannot be an alkene or alkyne with one carbon. Does this make sense? Yes or no? Please tell me. Can we move on?
Yes, sir.
ठीक है. Moving on. So this is the catalytic hydrogenation, which is over. Next is from alkyl halides. B part is from alkyl halides. ठीक है. In alkyl halides, we have two reactions. The first reaction is rather I should write it like one. First reaction is Wood's reaction. The second reaction is reduction of alkyl halide. Reduction of alkyl halide. ठीक है. Now, first of all, we are going to see the Wood's reaction. Number one. Wood's reaction. So in Wood's reaction, what's going to happen? ध्यान सुनिएगा. I hope you guys know that alkyl halide can be written like this: RX. ठीक है. R is the alkyl group. ठीक है ना. X is the halogen. X will be equal to either fluorine or chlorine or bromine or iodine. Right? You guys know this, right? Yes or no? Haloalkane in 10th standard maybe you have learned. Fine. Plus sodium in the presence of dry ether is going to give you R bonded to R plus NaX. ठीक है. करना क्या है यहाँ पे? ध्यान सुनिएगा जरा. So what you need to do is RX है तो आप एक R radical बनाइए, दूसरा भी R radical बनाइए और दोनों को अटैच कर देना है like this. I will give you examples. हम बताते रहेंगे. ठीक है ना. For example, you have CH3Cl in the presence of sodium and dry ether. क्या करना है आपको? CH3 it has chlorine ना, तो radical बना दो. CH3 इसका भी radical बना दो and just bond them. CH3 that is ethane plus NaCl. NaCl is not going to be important. The organic portions are going to be important. Organic reactant, organic product is going to be important. Make sense? Yes or no? Please tell me, guys. आ रहा समझ में? Yes or no? What you need
Yes.
to do? ठीक है. I will also even maybe I will add step. है ना? For example, if you have 3 carbon atoms and here you have chlorine in the presence of sodium and dry ether. Fine. So 3 carbon atoms, chlorine radical, 3 carbon atoms, chlorine radical. ये दोनों radicals कैसे बना दीजिएगा एक दूसरे के सामने? Where will be the radical? The radical will be on the atom which had chlorine. And then when you are going to attach both of these things, it will look something like this. Does it make sense? Yes or no? Please tell me. इन दोनों के बीच में बॉन्ड बना देना है. Does this make sense? Yes or no?
Yes, sir.
Sorry, guys. Similarly, if I have something like this and bromine, same sodium in the presence of dry ether. So 1, 2, 3 carbon atom radical, 1, 2, 3 carbon atom radical, है ना. इन दोनों को फिर आप अटैच कर दीजिए साथ में. So 1, 2, 3 bond and 1, 2, 3. Maybe how many carbon atoms? 1, 2, 3, 4, 5, 6 carbon atoms. Simple. Hexane. Does it make sense? Yes or no, guys? Tell me.
Yes, sir.
Similarly, if you have something like this, chlorine, sodium in the presence of diether, one radical here and the other radical here, just going to attach them. Make sense?
Yes, sir.
Actually, here also a few points that we can write. First point, it cannot be used. This method, है ना? This method, it cannot be used for preparation of alkenes with odd number of carbon atoms. है ना? It cannot be used for the preparation of alkene with odd number of carbon atoms. Why? Because the carbon atoms are going to double. So if you have one carbon, तो दो कार्बन का मिल जाएगा. If you have three carbons, six carbon हो जाएगा. If you have three carbons, again six carbon. If you have five carbons, 10 carbons. So always you are going to get an even number of carbons, an alkene with even number of carbon. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Another thing, the smallest alkane that can be prepared is ethane. The smallest alkane that can be prepared is ethane because the smallest haloalkane that we can use is of one carbon. और one carbon को double करेंगे तो ethane बन जाएगा. Does it make sense? Yes or no?
Yes, sir.
Fine. Next thing is that in order to prepare order in order to prepare alkane with odd number of carbon atoms, we need to take two different haloalkane, but it would give mixture of alkenes difficult to separate. ठीक है, ध्यान दीजिए जरा. What is the meaning of this last statement? For example, let us suppose I want to make this alkane CH3, CH2 and CH3 via Wood's reaction. Via which reaction? Tell me guys. Via
Wood's reaction.
Wood's reaction. So this can be made by this particular alkane. It can be made like this only. ना देखिए ध्यान सुनिएगा जरा. You can have CH3 radical और एक आपके पास CH2 CH3 radical होना चाहिए. By the combination of these two radicals only we can make. Yes or no guys, tell me. Make sense? बोलिए. Does it make sense? Yes or no?
Yes, sir.
And these two radicals we can have these two radicals if I have CH3, let us suppose Br, and we have two carbon, that means let us suppose Br, यहाँ पे CH2 and यहाँ पे CH2 and CH3. Now let us do the Wood's reaction using these two haloalkane. Can be made by we have used. So let us suppose we are doing this reaction. तो आपके पास है CH3Br plus CH2 CH3 CH2Br CH3 CH2Br. In the presence of sodium and dry ether, let us see what is going to happen. ध्यान सुनिएगा जरा. we will not be having only one methyl bromide. Na? If we are doing a reaction, we will be having millions and billions of methyl bromide. Does it make sense? Yes or no? Please tell me. That will be having millions and billions of methyl bromide. Are
Yes,
समझ
sir.
में? Right. So what is going to happen? For sure, you are going to get a CH3 radical, which will attach with CH3 radical, making this particular type of. That means this particular haloalkane will react with itself as it was doing before also. We had one haloalkane, then it was reacting, it was giving you ethane. So it's not going to wait for the methyl bromide. Sorry, it is not going to wait for the ethyl bromide. Methyl bromide can react with itself also. A similar thing is going to happen with the ethyl bromide also. 1, 2, 3. That means you are going to get this type of carbon atoms, 4 carbon atoms. Does it make sense? Yes or no? This will react with itself only. Hi, Anna.
Yes, sir.
Now, there will be certain number of molecules of methyl bromide which will collide with the molecules of ethyl bromide, and a very small amount of propane will be made. That means if I react methyl bromide and ethyl bromide, if I take two different haloalkane, then I get three different products, and all of these products will be having similar boiling point. So it is very difficult to separate them. So what are we? What are the products we are going to get? We are going to get ethane, we are going to get butane, and we are also going to get propane. What is the product that we needed? We needed only propane, and we are getting very small amount of propane will be there. Now, even if I take, let us suppose, like 33, 33, 33, तो बहुत ही कम मिला ना. ना, we were expecting 100% yield रहना चाहिए. That is why we do not do, and we do not prepare any alkane with odd number of carbon atoms via this method, via Woods reaction. Does it make sense? Yes or no? Please tell me.
Yes, sir.
चलिए. Next is reduction of alkyl halide. It's very easy reaction, reduction of alkyl halide. We may second part, है ना? Second part is reduction of alkyl halide. A simple reaction in which haloalkane, it is reduced in the presence of, reduced मतलब we're going to add hydrogen H2 in the presence of zinc and HCl, and you will, यहाँ से हाइड्रोजन हटेगा, हाइड्रोजन लग जाएगा, RH. ठीक है? For example, if you have CH3Br plus H2 in the presence of zinc, and in not HCl, they will give you H positive, है ना? Same thing. तो भी क्या होगा? CH3 में यहाँ पे 3 हाइड्रोजन, एक हाइड्रोजन बढ़ा दीजिए, बस CH4. That's it. Does it make sense? Yes or no? Please tell me, guys.
Yes, sir.
Zinc and H plus 3 carbon atoms. Does it make sense? Yes or no? Please tell me, guys.
Yes, sir.
बस आपको हाइड्रोजन हटाते चला जाना है. यहाँ पे लेट सपोज यू हैव क्लोरीन, zinc plus in the presence of HCl. Simple. Does it make sense? Yes or no?
Yes, sir.
Let me know if you're done. Oh no, why I'm waiting for you guys to done. ठीक है. Next is the, sorry guys, why was I waiting? The third method of preparation, third हो जाएगा ना? हाँ, is from carboxylic acid. It's very similar to the haloalkane part. ठीक है ना? दो reactions है, both of these reactions are going to be very similar to the haloalkane part. ठीक है? From carboxylic acid. The first one is decarboxylation, and the other one is coal-based reaction. Okay. Now, in decarboxylation, what's going to happen? अभी जो हमने जिंक और HCl वाला किया ना, बिल्कुल उसी उसी के जैसा है, बिल्कुल उसी के जैसा है. मतलब reagents are not like that, the formation of product is like that. That means in this you are going to have carboxylic acid plus you are going to take soda lime in the presence of heat. Fine. तो वहां पे RX हटता था, देखो जरा, RX हटा, RH हुआ, यहाँ पे COH हट के RH हो जाएगा, सिंपल, प्लस Na2CO3. What is soda lime by the way? So soda lime is a mixture of NaOH, sodium hydroxide से सोडा है, and lime is for calcium oxide. Does this reaction make sense? It's very similar to the previous reaction, yes or no? हाँ जी. So for example, if you have CH3, COOH, and in the reagent they are giving you NaOH plus calcium oxide in the presence of heat. तो फिर क्या हो जाएगा यहाँ पर? C, ये आप हटा देना, this whole is going to be removed and CH3 की जगह क्या आ जाएगा? CH4 plus Na2CO3 which will be obviously there. Now, for example, if you have 3 carbon atoms, 1, 2, 3 carbon atoms, COOH, the same reagent, COH हटा दीजिए, you will get CH3, CH3. ठीक है. Similarly, if you have something like this, let us suppose COH हटा दीजिए, you'll get butane. Does it make sense? Yes or no? Please tell me, guys.
Yes, sir.
चलिए. Now, this reaction can also be done if you have a sodium salt of carboxylic acid. For example, आपके पास क्या है? RCOONA है, and you use the same reagent, तब भी ये reaction हो जाएगा and you will get RH. ठीक है. सोडियम सॉल्ट ऑफ कार्बोक्सिलिक एसिड बोला जाता है इसको. ठीक है ना? दिस इज द सोडियम सॉल्ट ऑफ carboxylic acid. Fine. Now the another reaction, that is coal based reaction, it is very similar to the Woods reaction. मतलब सेम है, बिल्कुल सेम है. कैसे होगा? ध्यान सुनिए. B part is the coal based reaction. RCOOH. तो बेसिकली ना कोलबे जो है वो इलेक्ट्रोलाइसिस करता है, उसके लिए क्या, व्हाट डज ही नीड इज द सोडियम सॉल्ट. तो इसमें ना इफ फर्स्ट ऑफ ऑल ही रिएक्ट्स विद NaOH और आपको मिलेगा RCOONA. ठीक है. नाउ व्हाट यू आर गोइंग टू डू, RCOONA, इसका होना है पानी के साथ इलेक्ट्रोलाइसिस. क्या होगा इसका? इलेक्ट्रोलाइसिस ना. और आप कोल बेस्ड इलेक्ट्रोलाइसिस लिखा रहे हैं या फिर क्या लिखा रहे हैं? इलेक्ट्रोलाइसिस. करना क्या है आपको, हम आपको बता देते हैं. यहाँ से COONA को हटाइए, रेडिकल बनाइए, एक और रेडिकल बनाइए, इन दोनों को जोड़ दीजिए. वेरी सिमिलर टू द वुड्स वन. यस और नो? प्लीज टेल मी.
Yes, sir.
है ना? फॉर एग्जाम्पल, इफ यू हैव CH3 COONA electrolysis, what is going to happen? CH3 radical, CH3 radical, join them, CH3 bonded to CH3. If you have something like this, COONA electrolysis, radical, radical, just join the radical. ठीक है. चलिए. I will give you some. I'm just writing some questions. In questions, I will discuss it in the next class. Fine. So write the major products. Let me see what are the questions that I gave. वहां पे उनको भी यहीं पे इंक्लूड कर लेते हैं. ठीक है ना? Okay, fine. This was the question maybe. ठीक है, these are the 3 questions. This is on Wurtz reaction, sodium in the presence of dry ether. And let us take one more question here. अच्छा, ये सवाल शायद आप लोगों से ना हो, but still I'm going to give you guys. Chlorine, here also chlorine, sodium and dry ether. Fifth reaction, sixth reaction. Br, H2, zinc and H plus. 7 question. ठीक है, चलिए, just give me a second. I'm giving you this PDF. Please be in the class, है ना? आप क्लास में रहिए, आपको PDF just मिल जाएगा. I will send it in the Zoom chat. ठीक है? So this is hydrocarbon lecture 1. Hydrocarbon lecture 1. Just give me 2 more minutes. Fine. The file is being uploaded.